Hi Year 6, hope you're all well. This video this morning is going to be about maths, and I'm going to try and put a video every Monday up, every Monday morning for the next few weeks about the upcoming topic that we're going to be focusing on for the week in maths. As you can see, I have had a lockdown haircut. Hopefully you guys are sticking to sensible haircuts, and yes, as you can see, the paint spot that you lot always talk about is growing on my head, which I'm very excited for. Anyway, so this week in maths we're going to be focusing on angles. Now I know we haven't done a lot of this in school, but there are some things that we have done earlier in the year that can help you, and I'm going to try and go through some of those bits and give you some top tips of how you can approach maths for the week. Now, we're going to be using a lot of the White Rose stuff that we have that we've always used throughout the school. So in terms of the style of questions, they should be familiar to you. Now on the PowerPoint, at the top of one of the slides, there should be a set of instructions on how to find the right video link. Although I'm attaching most of the questions to the PowerPoints anyway, so just make sure you try and find at the top of the worksheet the set of instructions which gives you the exact video to look for, okay? Because it won't match up on what their current day is to what we're doing, because I've tailored it slightly different for you. Now, some of the questions on some of the questions on some of the days, it might go 1, 2, and it might skip question 3 and 4. That's just because I haven't included them because I don't think they're suitable for the home learning. So don't worry if there are missing questions, I've done it on purpose. And also angles. I'm sure some of you are wondering, well, how am I going to be able to do angles without a protractor? Don't worry about that. I've included all the questions that you don't need a protractor for, and we're mainly going to be focusing on using angles and calculating angles, within shapes in different variations. So don't worry about using a protractor. You don't need a protractor. We'll just be sticking to calculating angles. So what I'm going to try and do today, I've never done this before, so we'll see how it goes. I apologise if it's quite lengthy and I make a couple of mistakes, but in a second I'm going to share my computer screen with you so that you can see some examples and see what I'm actually talking about for the upcoming lessons. Now, I haven't sectioned it into lesson 1, 2, 3, 4, 5 and 6. I've just given you a progression. So the video will work in progression for the week, but I haven't sectioned it out. So you can refer back to this video at any moment during the week to kind of think, oh, what did Mr. Stevens say about this part of my learning? So you can watch the video as many times as you want. So here it goes. I'm going to try and share my screen with you now, and let's see what happens. Right, so hopefully you guys can see my screen now, and you should be able to see the little crosshair floating around my screen, moving around at the moment. It's going around, what do I know about angles? So before I start this, we need to ask ourselves, before anything, those same questions that we always ask you when we start a new unit of work, and that is, what do you know about something? So in this case, what do I know about angles? So you can see below, there are several different angle types. Now, you guys have told me lots and lots about the different types of angles that you know, and we have covered that roughly in some of our learning, but just not directly. So I'm going to go through them just really quickly now, and then we'll apply them in a little bit more detail later on in the video. So here we have got a right angle, and that is always marked by this square in the center. So the right angle is the measurement in here, and that would always be 90 degrees. So, and we've got a straight angle here, and that's an angle on a straight line. So angles on a straight line always equal 180. And then we've got the acute angle, which is the small angle that you guys talk about, and that is an angle that is less than 90 degrees. And then we've got the obtuse angle, so they're the fat angles, and they are angles that are larger than 90 degrees. And then the last one is the reflex. I always remember this because Miss Stevenson in her classroom, to get you to remember this, has got a cat doing a backflip. and the angle around its tummy is hyperextended, so it's got a large angle under its tummy, and that is the angle it's not this one here, because that would make it this angle an obtuse angle, but it's this one round here, which is that's what makes it a reflex angle, and that is an angle that is larger than 90, sorry, not 90 degrees, it's an angle that is larger than 180. So now I've asked myself a little bit about what I know about angles. I know that right angles are 90, angles in a straight line are 180 degrees. We've got acute angles, which are less than 90, obtuse, which are larger than 90, and then reflex, which are larger than 180. So applying angles. You can see on my screen at the moment that I've got some compass points. And on these compass points, we can use this to apply our angles. For example, moving from, or if I was standing in the center here, so if I was standing, let's get a circle out for you to mark where I'd be standing. So if I was standing here, that would be my center point. Now, if I move this arrow over to here, okay, now that arrow, at the moment, I'm facing north. If I move this arrow to east, I've turned 90 degrees, because this angle here, inside here, is 90 degrees. If I go back to the beginning, and I go from north to south, so from north all the way round to south, that has created a straight line from north to south. So that is 180 degrees. So we've gone 90, add 90, 90 and 90 is 180. Now I'm going to go from north to west. So north, east, south, west. Now, we know that angles in a straight line are 180. Angles there, like an L, are 90 degrees. I've moved 90, 90, and another 90, because I've got 90 there, 90 here, and 90 there. 90 add 90 is 180, add another 90 is 270. So moving from north to west, that has created a turning point at 270 degrees. And then the last one, if I move from north and go full circle, so 1, 2, 3, 4, that's 1 lot of 90, 2 lots of 90, 3 lots of 90, 4 lots of 90, that is 360 degrees. So when we turn full circle on something, that is 360 degrees, okay? So that's how we can apply that to this. Now, you see over here, I've got the word fractions. Mr. Stevens, what are you talking about? We hate fractions. Why are we doing this with angles? Now, I'll tell you why, because we can apply fractions to angles in a way when we're using turning points. So at the moment, I'm facing north. If I move to east, that is called a quarter turn. How many parts are there? 1, 2, 3, 4. There's 4 parts to my whole. Moving 1 part across, or moving 1 part round, that is 1 quarter. Now, if I was to move twice round, which would take me to south, 1, 2, that's 2 quarters. So that's a half a turn. Now, if I go back to north, from north to west, 1, 2, that's 3 quarters. So that would make it a 3-quarter turn. And then if I was to go all the way around, 360 degrees, 90, 180, 270, 360, that is my whole. So that is a full turn, okay? No parts to it, I've turned all the way around. So that's how we apply it to the directions that we can face and turning points, okay? Now we're going to move slightly on, and we're going to be looking at, and this is what you will come on to at some point during the week, is working with angles on a straight line. Now remember what I said earlier, angles on a straight line equal 180 degrees. So this is my straight line. I have an angle here and I have an angle here. Now at the moment I have a missing angle, so I can treat this as a missing number problem. So it would become 45 add A equals 180 degrees, okay? which I've got a missing number problem. So to solve this, we do the inverse. So we do 180 degrees subtract 45 equals A. So now I can do 180 subtract 45. Should be able to do that in my head. If you can't do that in your head, then you can use column subtraction. So I know I'm going to break 45 down into, I'm just going to make it 40. I know that half of 80 is 40, so that's, and I've got 140. Subtract another 5 that I haven't included yet, which is 135. So the missing angle is 135. Now to check that, what I can do is I can do 45 add 135. And again, I should be able to do that in my head. I'm not going to do 45 add 135. I'm going to switch it around because it doesn't matter. That's 135 add 45. So 135 add 40 is 175. Add the 5 is 180. Yes, I am. No, not 190, 180. There we go. So that's how we deal with angles in a straight line. Now, if we look over here, this one's a little bit different because I know on here, this line here is 180. So the angle all the way around there is going to be 180 degrees. However, I've got two missing parts. So if I did 180 take away 55, that would give me the angle of B and A. But I don't want that. I want two separate I want two separate answers for B and A. Now, can ask ourselves, what do I know about this diagram? Okay, I've been given 55 degrees. I know the total is going to be 180. B, I haven't got a clue how to work that out, but A looks familiar. If I go back, it's a right angle, and I know that right angles are 90 degrees. So if I go back here, I can make some notes on here, and that, not 99, that's going to be 90. So now I've got two of the angles and I've got one left. So now this becomes 55 add 90. Sorry about my typing. Add B equals 180. So now it's a missing number problem. So I would do 180 subtract 55 subtract 90 equals, and then I'll be able to find my missing number my missing number. Now I'm not going to go through the answers for that, just because I want you to be able to apply this to your work, and I'm conscious that otherwise I'm going to be spending 30 minutes on here and wasting a lot of your time. So I'm going to skip on to the next part. Okay. If at any point you want me to email, if you want to ask me any questions, just send them via an email. Okay. Now, the next thing that you'll probably come on to in your learning is working with angles that are opposite. Now, we have two angles, angle A and angle B, and you can see that they are opposite. They are exactly opposite each other. Now, I can ask, what do I know? What do I notice about this? I notice that actually angle A is the same as angle B. So angles that are opposite are always equal. Okay, angles that are vertically opposite. So angle A is the same as angle B. Now, if I've got a point here, let's use a compass point for reference just to give you a bit of an idea of what I'm talking about. So I'm going to stand move it to the right place. I'm going to stand here, I'm going to get my arrow, make it red so you can see it clear. I'm going to stand here. Now, if I move this angle all the way around, I've done a full circle. How many degrees is that? That's 360. So angles like this that include a full turn, that equals 360 degrees. So this angle adds that angle, adds this angle, add that angle. So add those 4 angles together, that would equal 360 degrees. Okay, let's get rid of those. So if we come over here, now we can see this angle here. There's lots of different lines here. So I'm going to get my pen just to kind of draw some bits in for you to have a look at, okay? So I am saying, or initially, when I look, this angle here is going to be the same as this angle here because they are opposite. Now, what people can make mistakes with sometimes, is, oh, we've got this angle here. I mark it with A, and I've got this angle here. Now, people can make the mistake. Now, I'm saying that this angle and this angle are the same. However, we notice that there is this line. It's not a very straight line. I apologize for that. Now, this distance here, you can see visually it is different from that there. Now, actually, the angle that I should be looking at, if I can draw a straight line, let's actually use a straight line in the right color. From there to there, that angle, those 2 angles, sorry, are actually the same as that. So B isn't the same as A. Actually, B is the same as A and C. Okay, so just be careful. And then we know that that angle, let's give you the pen so you can see me marking it. That angle, add that angle, add that angle, add that angle, add that angle must equal 360 degrees. Now, White Rose puts that in a lot better way than what I have just done. So watch the video for the beginning of the lesson on how to do this. And if you don't understand anything I've just said, watch that video because it does do it very, very clearly, okay? Now, the next thing you might come on to is working with angles in triangles. So we've got, well, we need to ask ourselves that same question that we always do in year 6 is, what do I know about this? In this case, what do I know about triangles? Now, you always tell me that you know of 3 types of triangles. We've got the equilateral triangle, which has 3 sides that are the same. Now, if these 3 sides are the same, that means all of the angles are the same, okay? Now, with the triangle as well, all angles in a triangle, they add up to 180 degrees. Now, there's an image, I think it might be on lesson 3 or 4, that puts this in a really good way for you to understand visually, okay? It gives you an image to look at, and it shows you why triangles add up to 180 degrees. So equilateral, 3 equal sides, which mean, and all of these angles are also equal. We've also got the isosceles triangle. So we know that this is an isosceles because 2 sides are the same, and it's that side and it's that side. Now, in your questions this week, you will see your isosceles triangles marked like this, and it just means that this side here is the same as this side here. So that means this angle and this angle have got to be the same. However, this one is different, okay? And then the last one is the scalene. So that just means that there are no sides the same, and it often it always means that all of the angles inside a scalene triangle are different as well. So this one will be different to this one, and obviously there are lots of different types of scalene triangles that we can get as well. The ones that we're going to concentrate on this week, you're mainly going to see isosceles triangles and scalene triangles. They're the ones that we're going to be dealing with in the most part. So let's have a look. Now, here we've got 2 types of triangle. We've got one that we didn't even put in our list on the last slide. So we've got a scalene triangle here. All of these are different. Scalene means all the sides are different. Over this one, we'll come on to this in a minute, but just think about it. One of those angles is a right angle. So actually it's a right angle triangle. It's not a scalene triangle. But let's focus on this one over here first. Now, what did I say about triangles? Angles in a triangle equal 180 degrees. You can also write 180 degrees as 180 not 1,800, 180, and you would draw, just ignore the buttons I'm pressing at the moment, a little O above it as well, okay, and that's the degrees sign, all right? So if you see a question, it might be written as 180 degrees using words, or it might be using the symbol here. You can see the 65 and the 70 and the 50 have got that little symbol in it, okay, that's all that means, don't worry about it. So like I've just said, angles in a triangle equal 180 degrees. Now, we've got two of the angles, but we're missing one of them. It becomes a missing number problem, exactly the same as angles on a straight line, okay? So what that becomes is this should be 70 add 50, add A equals 180. Again, it just becomes a missing number problem. So the way I would work that out is 180, not add, because I'm doing the inverse, remember, subtract 50, subtract 70 equals A. Now again, you should be able to do this mentally, okay? But if you can't do that, then you can use your formal written method of column subtraction. I'm going to do it in my head. Now, I know what I'm going to do is 180 subtract 50. Now, I know that the difference between 80 and 50 is 30, so that's 130. Now I'm going to take 130, or I'm going to take 70 away from 130. Now, to be able to do that, I know there's 20 in 70, and that takes me to 110 there, which leaves me with 50, and then I'm going to subtract another 10, which gets me to the 100. So now I'm on 100, and that gives me 40 left. And then take away 40, that is 60. So the answer would be 60 degrees. Okay, so A, go down here, A equals 60 degrees. And again, you can check that just by replacing the A with the 60, 70 at 50 at 60, 180. Brilliant. Now this one, we've only got one angle here, okay? But remember, all of the angles in this triangle should add up to 180. So what I would do here is I've got two missing angles. Remember what I said earlier, this angle here. If we go right back to the beginning, this angle is exactly the same, and it's got that little marker inside the angle, which means it's 90 degrees. So actually, I haven't got two missing angles because this one here is actually 90 degrees. So now, exactly the same as the process over here, I can calculate what I'm doing. So it should be, or it should read as 65, add 90, add X in this case, not A this time, equals 180. Now remember, it's a missing number problem, so I do the inverse. 180, subtract 90, subtract 65. Again, I'm going to say it one more time. You should be able to do this mentally, but if you want to do this the column subtraction, that's absolutely fine. Just work it out whatever way is easiest for you, particularly that you're doing this at home, okay, and without us. So moving on to the final part of the learning. So you will come across this probably on Thursday, I think, and then Friday's learning, where we kind of try and combine all of it, or we step it up a little bit, is we're looking at the second type of triangle, which is the isosceles triangle I talked about. Now remember what I talked about isosceles triangles? They have two sides the same, and that is marked by this line here and this line here. So I get my straight line this time instead of drawing wonky lines. That means that that side and that side are exactly the same, which also means this angle, no, I do need a wobbly line, which means this angle and this angle are the same, but this one is different. Okay, so now I know those facts. I'm going to ask myself, just double check, what else do I know about isosceles triangles? I think I've just answered all of that, but let's just reveal what it says. What do I know about isosceles triangles? Two sides the same, yes, we have noticed that. Two angles the same, yes. And then what did I say about all angles in a triangle? They equal 180 degrees. So now, what do I know about 70 and A? Oh, I said these two angles are exactly the same. So it's 70 and A is 70. So A equals 70. Okay, so now what I can do is I can build a number sentence. So 70, add 70, add B. What do angles in a triangle equal? 180. Equal 280. 180. Sorry, my typing again. Missing number problem, do the inverse. 180, subtract 70, subtract another 70, and then you would work out your answer. Okay? So 180 subtract 70. I know the difference between 70 and 80 is 10, so that's 110. 110, take away 70. So I'm going to take away 10 first and target the 100, which leaves me with taking away or subtracting 60. And then I would do 100 subtract 60, which would leave me with 40. Sorry, got confused then. So the answer would be 40 degrees. So this angle, B, equals 40 degrees. Okay, now that is as hard as it's going to get. Okay, there might be, just be careful with White Rose, because remember, sometimes they word the questions to trick you. So the maths, this is as hard as it's going to get. Okay, right, I'm going to unshare my screen now. Right, so I've given you a quick overview of roughly what you're going to do this week. Hopefully it makes sense. Again, I apologise if it doesn't. This is the first time I'm doing it, so I'll try and make it a little bit easier if it doesn't make sense for next week. Equally, if you've got any questions about the week ahead or any of the questions, just give us an email and we will try and put something together to help you even further, okay? We know that these are it can be quite difficult at home, so don't stress out about it. This is not meant to stress you out. If you don't understand something, it is absolutely okay. Remember, in maths, you've got the three options, okay? You've got times table rock stars, you've got the problem of the day that I put up, and then you've got your main learning, which is around the angles this week, okay? And you only have to do one of those. But give the angles a go, because it is new learning for you, and you guys deserve to have a full, even though you're at home, you still deserve to have the full range of the curriculum, okay? Right, let's see how it goes. I look forward to hearing from you, Year 6. See you later.